If you observe this picture, you will see plastic bags, sellotapes, spoons, bottles, cups, gloves, raincoat, etc. We use all these products in our daily life and they are made up of one common thing, that is plastic. So we are starting with a new chapter, that is Introduction to Polymer Chemistry. The development in polymer science has helped humans a lot. We cannot imagine our life without having elastomers, artificial fibers, and plastic. So, whether it is the wrapper of a candy or artificial heart, there is no other material that can replace polymers. Artificial heart components and heart valve are made up of polymers. Hence, we can conclude that we are living in the world of polymers. Polymer chemistry has evolved as a separate branch due to the enormous knowledge during the last several decades and also its increasing application in everyday life. Chemically, the structure of polymers is very complex. They are giant macromolecules. Macromolecules means bigger molecules. These giant macromolecules are made from repeating units which are derived from smaller molecules called monomers. The word polymer is derived from a Greek word poly, which means many, and mer stands for part or unit. So polymer stands for many parts. So when a number of monomers come together, it forms polymer. Polymers are high molecular mass macromolecules. There are organic as well as inorganic polymers. In this chapter, we are going to study about organic polymers. Also, we will be dealing with man-made organic polymers in terms of their types, preparation and applications. Now we are going to study the classification of polymers based on the source of their origin, on the basis of structure, on the basis of mode of polymerization, classification based on intermolecular forces, on the basis of different types of monomers used, and biodegradability. First, we will start with the classification of polymers based on the source of origin. Polymers here are further divided into natural, synthetic, and semi-synthetic. First are the natural polymers. Polymers which are obtained from natural sources are called as natural polymers. Natural polymers are further subdivided into two types, that are plant polymers and animal polymers. Plant polymers are obtained from plants. For example, cotton and linen is obtained from cotton plant and flax plant. Natural rubber is also an example of plant polymer since it is manufactured using latex that is obtained from the bark of rubber trees. Next are animal polymers. The polymers which are obtained from animal sources are called as animal polymers. Examples of animal polymers are wool, which is obtained from the hair of the sheep. Other example is silk, which is obtained from silkworm. Synthetic polymers. Synthetic polymers are the polymers which are made by man. So they are man-made polymers. These polymers are prepared artificially either by using one monomer or copolymerization of two or more monomers. Copolymerization means you can use two or more monomers which are different from each other. So same monomer would be AAA and copolymerization would be ABC, like that. Examples of synthetic polymers are nylon, terylene and neoprene. Synthetic polymers are further subdivided into fibers, synthetic rubbers and plastics. Next, we move on to semi-synthetic polymers. Semi-synthetic polymers are derived from natural polymers. They are also called as regenerated fibers. So here, the properties of natural polymers are modified by using chemical treatment. Example of semi-synthetic polymers are acetate rayon, cellulose nitrate, viscose rayon, and cupra ammonium silk. They are also used in non-inflammable photographic films, varnishes, and cinema films. Next, we move on to the classification based on structure. Depending upon the number of monomers linked together, polymers are classified as linear, branched, and three-dimensional cross-linked polymers. The linking in the monomer depends upon the nature and number of functional groups present between them. First is linear polymer, which is also called as straight chain polymer. Here, the monomers are joined in a linear arrangement or a straight line. It is obtained from bifunctional monomers or alkenes. Bifunctional means a single monomer has two functional groups. Example of linear polymers are PVC and high density polythene. This is a picture of a linear polymer. You can see that the monomers are arranged in a straight line. Each dot here stands for a monomer. Next is branched chain polymers. If a monomer has three functional groups or side chains, then it gives rise to branched chain polymers. Example is low density polythene. If you observe this picture, you can see that there is a branch on the sideways. So there is a division that is observed in branched chain polymers. Next is cross-linked polymers. This is the third type of arrangement. They are also called as network polymers. In this polymers, cross links are produced between linear chain polymers. This cross link is a result of polyfunctional monomer. Polyfunctional monomer means a monomer which is going to have many functional group. Examples of cross-linked polymers are bakelite and melamine. This is a picture. You can see these are the cross links which are connecting the linear chain polymers. Next, we move on to the classification of polymers based on mode of polymerization. Polymerization is a process in which low molecular mass compounds are converted into high molecular weight compounds by linking together the repeating units monomer by covalent bonds. So the low molecular mass material which consists the reactive groups are treated with high pressure or with the help of catalyst or by applying high temperature, hence converting it to high molecular mass material. There are three modes of polymerization based on the type of reaction that takes place between the monomers. First is addition polymerization, which is also called as chain growth polymerization. Second is condensation polymerization or step growth polymerization. And the last is ring opening polymerization. Addition polymerization is a process where addition of monomers take place without elimination of any small molecule. Hence, the polymer that is formed is going to have the same elemental composition as that of the original monomer. Compounds which have double bond undergo addition polymerization. It is also called as vinyl polymerization because most of the monomers that are used belong to the vinyl category. For example, vinyl chloride, which is having a formula CH2 double bond CHCl, acrylonitrile with the formula CH2 double bond CHCN. Also, the formation of polythene from ethene is an example of addition polymer. In addition polymerization, free radical mechanism is very common. Hence, it is also called as chain reaction. There are three steps involved: chain initiation, chain propagation, and chain termination. The chain reaction is started with the help of a free radical. Free radical is an atom, molecule, or ion which has unpaired valence electron. An initiator. Initiator is the one which starts the reaction. So it could be a catalyst like benzoyl peroxide, acetyl peroxide, terbutyl peroxide, etc. And they can be used to produce the free radical. We are taking the example of acetyl peroxide, which produces the methyl radical. So this is the formula for acetyl peroxide. We know that a bond corresponds to a pair of electrons. So if we break the bond between the two oxygen atoms, then each of the electron will go to the oxygen, giving us two molecules of CH3 C double bond OO, which forms the acetate. If we further eliminate carbon dioxide, then we are left with CH3, which is the methyl radical. Why is that one dot above CH3? Because the valency of carbon is 4 and we have only 3 H atoms attached to it. So one valency is vacant. Hence the formation of free radical methyl. The free radical methyl formed here, consider it as R dot. The subscript dot here stands or indicates free radical. This free radical then attaches itself to olefin or the vinyl monomer to produce a new free radical, which is made up of two parts, that is the attached radical and monomer unit. So we are taking the free radical, which is denoted by R dot, and we are going to attach it to a vinyl monomer with the formula CH2 double bond CHY, giving us a new radical, that is RCH2 CHY. Here the free radical now attaches to the vinyl monomer, so the valency of the carbon is complete. So the dot from the R has now disappeared and it has moved on to carbon with the H and Y group, because their one valency is incomplete. It has only 3 valencies that have been filled up. The next step is chain propagation. Propagation means increasing in number. The new radical, which is formed in the chain initiation step, now reacts with vinyl monomer again to form a bigger size radical, which will further react with another monomer molecule, and this sequence is going to repeat very rapidly, thus giving rise to chain propagation. Since there is repetition of sequence, it leads to high molecular mass radical. The last step is chain termination. Termination means to stop. Here the growing chain is stopped. The termination is done by combination of two growing chain radicals. Here is the example of chain termination process. Just write the two growing chain radicals in opposite direction to terminate the chain. Next is the condensation polymerization. Here we are taking the example of formation of terylene. Ethylene glycol is reacted with terephthalic acid with the elimination of water gives terylene or dacron. So when water is eliminated, the two molecules are linked together by the ester link. How are you going to define condensation polymers? It is the process of formation of polymers with the elimination of small molecules like water, hydrochloric acid, methanol, and ammonia. Chain growth occurs in condensation polymers with the help of condensation steps, that is, with the elimination of small molecules. Hence, it is referred to as step growth polymerization. Similarly, even this process is continued till high molecular mass polymer is obtained. Last is the ring opening polymerization. Cyclic compounds like lactams, cyclic ethers polymerize by ring opening polymerization. A strong acid or a base is used to catalyze this reaction. Example of ring opening polymerization is the polymerization of epsilon caprolactam. So as you can see in this reaction, the structure of epsilon caprolactam is cyclic, and when it undergoes the process of polymerization, the ring structure is opened in a linear arrangement. Ring opening polymerization proceeds by the addition of a single monomer unit and not a larger unit to the growing chain. Hence, ring opening polymerization is a step growth polymerization like condensation polymerization. Now we move on to the classification of polymers based on intermolecular forces. The mechanical properties of a polymers, which are tensile strength, toughness, elasticity, etc., will differ in different polymers depending upon the intermolecular forces. There are four types of polymers based on intermolecular forces, which are elastomers, fibers, thermoplastic polymers, and thermosetting polymers. First is elastomers. If you observed a rubber band, when you apply external force, that is, when you stretch a rubber band and you leave it, it gains its original shape back. So, rubber band is an example of elastomer. Hence, elasticity is a property by which a substance gets stretched on the application of external force and is going to restore its original shape after the removal of external force. Elastomers are also called as elastic polymers, and the type of intermolecular force present between them is the weak van der Waals force. This force is responsible for the stretching of a substance. There are certain crosslinks which are present between the chains, and these crosslinks are responsible for the regain of the original shape after the removal of external force. Some examples of elastomers are Buna N, Buna S, neoprene, and vulcanized rubber. Next, we move on to fibers. Polymeric solids which form threads are called as fibers. These fibers have high tensile strength and hence they do not break if tension is applied. This property of fibers is due to the strong intermolecular forces like hydrogen bonding and strong dipole-dipole forces. Due to the presence of strong intermolecular forces, fibers are crystalline in nature. Examples of fibers are polyamide, polyester, etc. Next is thermoplastic polymers. If a substance is easily shaped or molded, then the property is called as plasticity. When you heat a thermoplastic polymer, it is going to become soft, and when you cool it, it becomes hard. They have moderate, strong intermolecular forces, and they have the properties which are intermediate between that of elastomers and fibers. Examples of thermoplastic polymers are polyvinyl, polythene, polystyrene, etc. Last is thermosetting polymers. They are rigid polymers, means they are hard. When this polymer is heated, you can provide a shape to this polymer, but it becomes hard when it is hot. So once it becomes hard, you cannot heat it again and make it soft, and hence it cannot be remolded. What is the reason that this polymer cannot be remolded? Once this polymer is hot and it is poured in the mold, there are lot of crosslinks which are formed with the help of covalent bond during the hardening process, or you can say the setting process, while it is hot, and that is the reason that you cannot make it soft again by heating. Example of thermosetting polymers are bakelite, urea, formaldehyde resin, etc. Next is the classification of polymers based on different types of monomers. Here, the polymers are divided into two classes, homopolymers and copolymers. What are homopolymers? The polymer which has only one type of repeating unit is called as homopolymer. Hence, they are formed from a single monomer. Example is polythene, nylon 6, nylon 6,6, etc. Next are copolymers. These are the polymers which are going to have two or more types of repeating units. Hence, they are formed by the polymerization of two or more different types of monomers. Example of copolymers are Buna S and Buna N. Last is the classification of polymers based on biodegradability. Most of the synthetic polymers, These are the polymers which are made by man in the laboratory using the natural polymers which are available, and microbes do not affect them, and so they are called as non biodegradable polymers. Since they are non biodegradable, they are going to remain in the environment for a very long time, which is going to result in pollution. However, the natural fibers are biodegradable. So, in order to tackle the problem of environment, scientists have now come up with biodegradable synthetic polymers. So, this was all about the classification of polymers. This is a tree diagram which shows all the classes of polymers.